Dr. Mel with a quick lesson on body composition. I'm thinking, why do I care about this? Because a lot of machines, I get a lot of clients that ask me, is this a good machine? Is it worth spending the money to do these things? If you're in the field as a personal trainer or fitness professional, strength conditioning coach, whatever, maybe you should understand how these body composition machines work and just what body composition is. There's also a lot of confusion, I think, many times about some of the terms that are used, like lean mass versus muscle mass versus fat-free mass. And so this little video might help clear up some of that and give you some background. So our bodies are broken down into 4 components, and that's how that's the most accurate way to determine true body composition, if we can actually break down the body into these 4 components. Now, these different components here are not necessarily to any sort of scale, but you will see that the majority of what makes up our body is water, so body water. Now, many of the machines that are out there, okay, or methods of determining body composition, let's say like a bod pod or a hydrostatic weighing, okay, will group the body into 2 groups, lean mass or fat-free mass and fat mass. And so of that lean mass group, body water is the biggest, okay, bone be next, and then muscle, what we're usually interested in, and like things like glycogen storage, so proteins, okay, as well. So glycogen, protein, all these different other section, but muscles, what most of the time we're talking about. So when people say lean mass, that's not muscle mass. At least it's not supposed to be. Lean mass encompasses all 3 of these. Okay, fat mass is fat. Fat is fat. And so this 4-component model then can be broken down in what's called a 2-component model, which is majority of the devices out there. Now, DEXA, if you're familiar with that, DEXA does 3-component model, and what it does is it can assess bone. It's a bone scanner after all, and so it can break down these 3 tissues and then only estimates water. So that's why a 3-component model is going to be more accurate than a 2-component model. 2-component model, again, examples of 2-component model body fat analyses are bod pod, hydrostatic weighing, skinfold analysis, which has the added layer of the practitioner has the pull of the skin, right, pinch it, skin fold, okay, fold it over. I've done many of those over the years, and there's a lot of potential error, especially if somebody has more body fat, and so that can be problematic. But the 2-component model is what most of these models operate on. Okay, the 2 components being lean mass and fat mass, or fat-free mass and fat mass. Now, the problems come, especially with these 2-component models, is fat is fat. Okay, so 0.9 grams per milliliter is fat is fat. But lean mass, we have to estimate, because bone mineral density, if you have a higher bone mineral density, let's say you're a swimmer, you might have lower bone mineral density than the average person. And so your fat-free mass, what we assume to be 1.1 could be different. It could be lower, potentially. You could be less dense in your fat-free mass. You could have a higher bone mineral density. And so reality is this is going to help you, because now it's underestimating what your average fat-free mass should be. Okay. And so this is where some of the problems come when we have error. Fat is fat, but we have to make a determination about what's the density of this other group of tissue. And if we're wrong, this is why there's many equations to try to adjust for ethnic diversity, different in ethnic groups, between the sexes, sex by ethnic group. There's equations that can try to account for these differences that we see in different ethnic groups, like bone mineral density is one of the biggest. Again, that can be problematic. That's why you have to be careful. In some groups, you hear like somebody's 1% body fat, and you're like, I don't think so. If they're 1% body fat, you can see their kidneys poking out their back as they run. I mean, so we have to kind of be mindful of that. That can introduce error. Okay, and that's where the majority of our error comes. Certainly on the modeling. Now, I mentioned skin folds. The person taking the skin folds can also introduce error, not pinching in the right spots, inconsistent pinching from one to another, you name it. I've doing hundreds of these. I can tell you that can be probably somebody sweaty, trying to pinch a sweaty person. You might as well just give up, right? And you should, because it's not going to be an accurate measurement of skin fold. So anytime you add an extra layer, the device that's actually being used, is it calibrated? All those type of things. If you've ever done a hydrostatic weighing or seen that when somebody goes under the water, depending on the device, like if you use like a meat scale, I mean, that arrow, the needle is bouncing all over the place, and having somebody blow all their air out as they go underwater is it's a backwards way of doing things. And so there's a lot of error at each one of these steps. Okay. The bioelectric impedance devices have become more popular, the full body bioelectric impedance devices, and those actually tend to be more accurate than some of these other things like the bod pod, because they break the body, like I mentioned before, down into 3 components like the DEXA does. And that's why there's this value. Now in the research literature, you can actually test for body water and then do something like a DEXA, combine the two, and then you got yourself a pretty accurate representation of body composition. And so it just requires more steps. All right. So, I hope that's helpful when, when you're thinking about, is body comp measurements effective? How do they work? It's fat versus fat-free mass. However much you can measure this fat-free mass accurately is going to improve the precision of the percentage of body fat then. But even DEXA can have problems trying to distinguish tissues, right? And different programs could be better or worse depending on the DEXA. So a general range in terms of error is 1% to 2%. You'll see that published most of the time. Skin folds maybe as high as 4%, maybe even higher, depending how good somebody is. Some of the handheld BIAs and just their scale, that could be as high as 4% because they're only measuring one end of your body. Body temperature can influence it. Hydration status can influence it. Again, you're not getting the full body. You're not going through the middle of the body where, that's where most of the body fat will be stored for many people. So again, that's where we introduce error. Okay. So the question is, should you do body composition testing? And the answer I have is yes, but you need to appreciate the percentages, the error bars that are associated. Years ago, I did hundreds of bod pods when I was a doctoral student. And there's many examples I give you. One of that comes to mind is a figure model came in. And she had to reach a bikini contestant, came in, and she had to reach a certain body fat percentage. And she was already at 15% when she started. And then she came in and she went to 15.5 and was distraught. Now she, just from, looking at her physique, she had leaned down. She looked a lot more defined in her musculature, but the bod pod was a 2% error. And so any wiggle under 2%, she could be less, which is probably likely, or she could be more, but you can't say for certain that she had seen a change. So I think these devices are great. These assessments are fine, but you have to still use some other things. You have to use them as a triangulation piece. So in other words, waist circumference, arm circumference, leg circumference, body weight, clothing fit, strength levels, right? These are all other measurements that you can combine with these body composition tools, assessment tools, to see what's really going on. I would not lean on any one body composition analysis as being, the way to determine your success. Just because of the error, just because of the different ways that you measure fat-free mass, just because of some of the assumptions that are made, there can be, it can cause some unneeded distraughtness. If your clothes are fitting better, your waist has come in, and the scale is down 5, and you're still blasting in the gym, and your body composition is negligible, like there's a negligible change, I wouldn't worry about it at all. I would say it's just the error in the machine. All right. So that's my advice on understanding body comp. We found this little lecture not too confusing. Hope it wasn't all over the place too much. It's an interesting topic, and it's certainly an important one, whether you're somebody who's a consumer and you want to know, how you're changing if your program's successful, or if you're a coach or a fitness professional and trying to use some of these devices. Maybe in future videos, I'll go over some of the limitations of these devices, but many of them are just traced to this, either a 4-component model becoming a 2-component model with assumptions, or, leaving one part of the model undetermined and still have to make assumptions, or just doing a poor job of actually getting a measurement that is of interest to begin with. Again, like the example would be the skin fold. All right. If you like this video, like it. If you have a comment, leave a comment below. And of course, subscribe to my channel for new videos posted all the time in the field of exercise, sports science, nutrition science. Posting 5 to 7 videos a week. I hope you're finding them valuable as you're going through the library.